Hello, Shivam. Wait, what was that? Was that an earthquake? Wow, that was a big one.
It was not just an earthquake. It was I, magnitude, controller of earthquakes. I'm here to wreak havoc on your city. Fear me.
Magnitude, there's nothing to fear from you. Imperium, the captain Vanuatu, designed to handle earthquakes. Are you new here?
Yes, I came to Imperium for a sweet tan. I love the tropical climate with temperatures averaging 73 to 82 degrees.
Not only is our climate great, but our snorkeling and diving is fantastic. A huge tourist draw. With our vertical fish farms, we no longer need to source our food from the ocean. 100 years ago, our population was 45,000 and growing at 2%. Our heritage was to grow our food of fish, but our waters were overfished and arable land was scarce. We need to rethink how to support our future population of 320,000.
Vanuatu is in the Pacific Ring of Fire and regularly experiences earthquakes. I can easily make one happen and take down your power grid with a snap of my fingers. Ha ha ha.
Not in our city. Our engineers use the engineer and design process to build an earthquake-resistant city. They identify problems, brainstorm solutions, and design, build, tested, and improved solutions. Knowing that earthquakes rise of much of a part is Imperium's culture is fishing, they began by creating strong building codes.
City officials knew that citizens can be hurt if buildings collapse from seismic disturbances and soil liquefaction. Earthquakes can also damage gas and electrical lines, causing fires. Long-term effects can include lack of food, water, and shelter. Citizens located in rural areas are more vulnerable to long-term effects.
Yes, Imperium is at risk. I can take down your power grid in several ways. The generation source, or knock down transmission lines with flying cheese or rocks, destroy substations, or obliterate distribution lines.
No, you can't. Our island uses sustainable power sources that can't be destroyed by earthquakes. Mechanical and electrical engineers identify green and blue energy sources.
Green and blue, what?
Green energy includes wind turbines here in the hills. Buildings include solar cells and generators running on coconut oil to provide backup power.
Blue energy is Imperium's best energy source using the ocean's tides, which can be predicted for thousands of years. As you can see here, tidal energy is harnessed by 20-meter diameter turbines suspended from a floating platform anchored to the ocean floor. The turbines are spun by water movement as the tide rises and falls.
Water's kinetic energy, 1,000 times denser than wind's, generates 4 megawatts per turbine. Engineers built 6 tidal generators around the island for a total generation of 96 megawatts. A trade-off to using tidal power is that no energy is generated when the tide direction changes.
Well, your generation sources aren't secure, but that leaves the rest of the power grid at my mercy.
You used the word secure. That's acronym for how the city protects its citizens.
Hi, you think that system can stop me?
I'll show you with our model made with recycled parts. Let's start with S for city smart grids, which monitor the power wirelessly. If the smart grid detects a failure, emergency measures are immediately taken.
Can you give me an example?
Sure, let's say that a transformer blows in this neighborhood. The fault is immediately alarmed and emergency workers are dispatched to fix the problem.
But the lights are still on here.
Yes, buildings include battery backup that can run emergency lights from the integrated solar panels.
But I cause destruction anyway. I make roads impassable.
That is what the Insecure stands for. We have emergency drones.
Imperium releases drones to fly over the affected areas, scanning and wirelessly uploading images that can be compared against pre-earthquake images. Computers rapidly identify the damaged areas.
Rescue teams are sent where they're needed most, using safe travel routes. Supply drones fly food, water, and medical supplies to remote areas, help citizens trials to restored. If citizens are seriously injured, larger drones fly in first, responders fly out the injured.
Well, that only helps a few people. With the disruption of supply routes, people will not have food and water.
That's what the C in Secure stands for. We have compact green communities. Civil engineers design spacious buildings with mixed residential and commercial use. Most services are within walking distance, and transportation options include autonomous cars and a maglev train.
The communities use renewable energy sources, but they're also literally green, with trees, parks, and farms inside the buildings. Food is raised locally through community gardens, as well as vertical fish farms, keeping Vanuatu's agriculture traditions intact. Green communities add to the health and happiness of the population, encouraging exercise and decreasing stress among citizens.
Rainwater is collected and filtered by porous concrete along roads and walkways, reducing erosion from storm runoff and providing local clean water. Filtering fresh water requires 45% less energy than the old method of desalination.
Smart. Local water treatment using reverse osmosis raises the cost of building construction. However, the benefits of local clean water during natural disasters and the energy savings outweigh the trade-off of the higher costs.
The buildings are designed using earthquake hardening techniques such as solid foundations in bedrock, rubber shock absorbers, and cross bracing. The buildings use resiliency measures such as safe assembly zones, supplemental shelters, and emergency power generators.
Local food and water supplied by compact communities protect citizens from supply chain disruptions. Before buildings are permitted, they are evaluated against environmental and sustainability criteria, as shown on the table here.
I put elderly and children most at risk when earthquakes hit. I close schools to prevent the elderly from seeing doctors.
Resilient buildings contain parks and exercise areas for citizens to enjoy their time until all services are restored. Vulnerable citizens are flagged by the smart grid and comparative backup power, and health clinics are in each compact community. Ha!
Ha! I'll take down your transmission wires. They're no match for falling trees or rocks. Wait, where are they?
That's what the U in Secure stands for. We have underground wires, avoiding above-ground damage. Civil and material engineers design graphene nanoribbon transmission lines, a flexible and resilient material.
Fine, if I can't take down your transmission wires, I'll take down the whole macro grid.
Well, that's what the R is for. We have redundant systems. Imperium is divided into 5 macrogrids. If one fails, the smart grid detects the failure and reroutes the power from another grid. For larger failures, the smart grid prioritizes vulnerable citizens.
In larger outages, we have high-altitude wind turbine balloons that can be plugged into compact community microgrids. Our drones can deliver solid-state batteries to critical locations, such as hospitals, food production, and public safety.
No, not solid-state batteries. Solid-state or plastic batteries still work if punctured and do not explode like lithium batteries.
That's right, Imperium is secure.
Wait, I thought secure is spelled with an E at the end.
We through the last EOA because earthquake emergencies became a thing of the past.
What are you, some sort of engineering superheroes?
I suppose so. Well, Magnitude, it looks like you've been demagnified.
I'm gonna go shake things up at the beach.
Oh, I'm first? Yeah. My apologies. Excellent. What vulnerabilities to today's power grids did you address with your futuristic design?
So for today's power grid, some of the transmission lines that we have, they are generally above ground, so they could fall over during an earthquake. So we put them underground and made them out of strong material so they wouldn't generally break.
And the material is called nanographene transmission lines, and they use, it's really strong and flexible, and it's stronger than steel, so that's why we used it.
And in addition, the nanographene, it's also conductive, which helps our electricity go through it.
Also, we have our electrical grid. We turned into a smart grid so we can monitor any use of electricity. So if we find a spike of electricity right before an earthquake, we'll use that to help us narrow down our search and try to make sure that we're using the most effective plans possible for our first responders to find any survivors.
Thank you.
So besides the power grid, what other ways is your city resilient?
So our macro grid, so if the smart grid detects failures and when it is always monitoring, so when it sees that one macro grid has gone down, it immediately reroutes the power and reabsorbs it.
In addition to our buildings, like we said earlier, we use cross bracing and rubber shock absorbers to make sure that they don't fall over.
We also have our compact green communities, which make sure that in a natural disaster, since everything is within walking distance, you can easily walk over to the nearest shelter that probably has food, and you can go get your food there.
In addition, we also have our solar panels and our turbines, wind turbines that can be plugged in. They're inflatable, so that also helps with giving power directly in emergencies.
And in addition, at the top of our buildings, we have computer-controlled weights, which sort of acts like a pendulum. So if our building's starting to tilt, it can swing the other way and bring it back to the center.
So you mentioned a little bit about autonomously driven vehicles. Tell us about the transportation in and around your city, mass transit, anything about the transportation system.
So most of our stuff, as we said before, is within walking distance. So a lot of the close range stuff you can walk to.
We also have autonomous cars. So the good thing about autonomous cars is that about 34,000 people are hurt or killed in car crashes. Also, about 1.7 billion people are injured. So that reduces, and it's by human error. So that reduces the risk, and also we can use the parking lots from the cars because they're not all they have one area where they all stay. We can make those into parks.
And in addition, for large mass transit, from one place to the other side of the city, let's say, we have a maglev train, which can travel at high velocities to the end location.
We also have our elevated hyperloop up on top of our buildings for close range quick transit.
Also, our elevated hyperloop, it's because some people, if they work near the top of the building, they're not going to want to have to go all the way to the bottom to get to another office at the top of the building. And then, so we have the elevator hyperloop as well as sky bridges and sky cycles.
I'd like you to discuss the full range of what these inhabitants in the city as far as employment goes. I just have some real questions about engaging all the population in employment.
So if let's say they aren't employed and they can't find a job, we give them job training, and we give them let's say they're very low income, we make sure that we sponsor them and we give them money for house and food for a certain amount of time or until they find a job.
And in addition, we also have our low-income housing. Like, if someone wants to build a mega tower that's 50 floors, we make an agreement like maybe 20 of them have to be low-income housing.
Yeah, so in addition to what he said about low-income housing, we give in addition. So for them to build higher, we give them permits. So so they would have to make the lower levels income.